Hello and welcome to Learn Data. I'm Nilesh and today we are going to look at regular expressions, a walkthrough example. And in this particular video, we'll connect on what we learned in the previous video and actually work on an example such as this one where we have a long string which is a multi-line string, and we are going to extract information from this string using regex and create these two data frames. So this will be kind of interesting exercise for you also to see how we can use regex to extract information. Now let's head on to Jupyter notebook. I've already created a new notebook and imported three libraries: numpy, pandas, and regular expressions. In addition, I've created this data string and I'll post this string in the description of this video, so you can copy it and paste it in the notebook. The string, let me explain this. So here the first line is within two square brackets, and that is the part of the string that's just telling that this is a made up string and it's not real data. And we won't need that, so we'll remove that and use just this part of the string. Okay, and to do that, let's go ahead and get started. So first thing that we are going to do is we are going to get the text that we are looking for and set it aside for further processing. And I'm going to create few more cells here. Okay, so p is equal to p. As previous video, we are going to use that as a variable to store a pattern, and within quotes we are going to specify the angle bracket that where we want to create a split or cut in that string. And because this is a meta character, we need to use backslash to escape it, and that's how the pattern will look like. Now we'll create another variable called dlist, and in this we are going to use re.split p comma s, and this is going to split the string and create two strings, as we can see here. Sorry, let me go ahead and run this again. Okay, now when we run this, we have a list which has two strings. The first string is the top row, the first line right here, and as you can see, it when we split the string from the closing square bracket, we got this separated out and that is at index 0 and this is at index 1. So now what we can do is we can go ahead and type d underscore node is equal to dlist and 0. So that will store the top line, and then d underscore text is equal to dlist and 1. So that will store the second line, which is the text. Now when we run this and look at what we have in the d text, this is the string that we have, and that's what we are going to use now. As a next step, this is like a pre-processing. We are going to remove blank spaces in the string, and as we are working through this particular exercise, it's important to note that there are multiple ways to achieve same thing. I'm sure some of you may already know better methods than what I'm showing here, and that's perfectly okay. Here the object is just to show how we can use regex to extract information from that string. So for removing blank spaces, we again have to create a pattern, and this would be we have a space, and that's the space we want to use. However, if we just put space, it's going to remove the space that we need, such as between words. So we want to keep that, and we want to remove the space that's long space like this one or this one, and that space is more than 1 in count. So here in curly braces we can specify that the spaces have to be more than at least 2, and they can be up to maybe 5 or 10 spaces. And when we run this and store it in a variable dt, so we can say re dot sub, and we are going to use sub here because we want to replace the whatever is in the pattern by the single space like this, and we are going to use the text string that we created just now for that. Now when we run this, we get a new string, and as you can see, these extra spaces that were there before have now been removed, and now it's much cleaner string that we can work with. Next step, we can now start looking at the company information. So get company information, and to get the company information, I'll create a mark. Okay, this is listed right here in the last line where it says contact us. We have the email and phone number, and within email we have the name, the company, domain name, etc. And the company names are also listed right here, and all of them start with a letter S in front of them. So let's see how we can pull the company information from there. So first we need to get names, and to get the names, what we are going to do is use the patterns p is equal to, and we know that both these strings for the company name, all these strings are within double quotes, so that's really helpful, and we can use that to our advantage. So we can, within quotes, we can type one quote, and then within this we can type dot for all the characters, and then plus sign, then we'll use a question mark here to limit it to only that particular last quotation. And c names is the variable where we'll store this information, so dot find all p and dt. And now when we look at c names, so c names, we see that we have the names of the company pulled from this large string that we had. And the way this particular expression was built, so it takes trial and error. I've already worked through this example and found that this is the particular regular expression that works in order to save time on the video. So you may have to go through several attempts to kind of find which regular expression works best. So it's okay if you do not get the expression working in the very first go. Next, what we are going to do is look at how we can get the email. So let's see that, get email, and for getting the email, again we need to write the regular expression, which is, now the email has a really interesting structure. We have this first part separated by ampersand, and then we have this second part which is again separated by a dot, and then we have this last part. So these three parts of text can contain anything, letters, on anything alphanumeric. So we can use that to create the pattern here. And we know that to select all alphanumeric characters, we want type A-Z, capital A hyphen capital Z, and 0 to 9, and then 0 to 9, and then one underscore. And after this, we want that to be repeated so that the entire text is covered until we reach the ampersand. And then after that, again we are looking for that alphanumeric part, which is this, and repeat it until we hit the dot, which is this one, and then again we search for the alphanumeric part of that string. So this would be the pattern that we can try to use and see if we can extract the email address from that particular larger string. And to save it, we'll save it in email. So re.find all p and comma dt, and now if we print email, so we got the exact email address out from this string. And this is really neat because we just by using a regular expression we could isolate that text for the string and save it in a separate variable that we can use now. Next, let's look at how we can get the domain name in a similar manner. So get domain, and to get the domain name we'll use a similar approach where pattern would be equal to here we would again use the alphanumeric set because we are trying to now get just this part of that string, okay, and plus, so that will continue until we hit the dot, and then we are looking for alphanumeric strings beyond that. And when we save this as a domain is equal to re.findAll p-dt email, now sorry, this would be domain, and we get all the three domains that we have for the three companies, and that we can now store it in a separate data frame using the variable domain. Next, let's look at how we can extract phone numbers. So for phone numbers, again it has a special structure. It starts with a plus sign, then we have 2 digits, then there is a hyphen, then there are 4 digits, then there is a hyphen, then a couple more digits. So the pattern that we can create based on that arrangement of numbers and characters could be something like this. So get phone, and here we'll say pattern p is equal to, in open quotes, the dash backslash plus, because plus is also a meta character, so we are escaping that. And then after that we are using backslash d plus. As you saw in previous video, that will identify match all the numbers. Then we have a hyphen, so after that we again have numbers, so this will match that. Then we again have another hyphen, and then we have another set of numbers there. So this should work and match the entire phone number that we are looking for. So when we'll type re.findAll p-dt and look at the phone, here we can see that we have the 3 phone numbers, so that's really good. We were able to extract company name, email, domain name, and the phone number as well. And finally, what we also would like to find is the count of trees that they planted. So I should have talked about this earlier. So we are talking about 3 companies who are planting trees to save forest, and that's the text about. So in this particular case, they have planted this number of saplings, like small trees, in the forest to save the forest. So we can, and we are assuming that they are in the same order as the company names that are listed here. So let's see how we can pull that information. If you've noticed, in the string these numbers are pretty large. They are more than five digits, so as compared to other numbers. So we'll use that information to create the pattern for regex. Let's go ahead and create another heading, get counts of saplings, and here when we type this, p is equal to open quotes comma backslash d, and here we type 5 and 10. So at least 5 digits have to be there to match this particular pattern. And let's see how this works out. We'll save it in a variable called sap, then re.findAll, and within here we have p comma dt and sap. So this, now we were able to isolate all these strings for numbers, and that's really awesome. Next, let's look at how we can identify the volunteers. So if we scroll up here and look, there were 500, 245 and 793 volunteers from each of these companies, and these again will assume that they are in the same order as the company that is listed. Now the challenge here is that although they are three digits, there are other digits also in here that are 3 digits. So what we are going to do here is we are going to use these where and volunteers as a method to cut it short and use that. In real actual situations, there are probably other solutions that could be used that would be much wider and not as we are hard coding that sentence here, but it should be okay for this exercise. So to get volunteer, what we can do first is we'll create a pattern to extract all the text that's within these 2 words, and then we'll save that in the variable re.findAll p comma s, and then we'll see what we get here. So when we run this is the string that we get in here. Now if we want to get the string out of the list, we need to use the index 0, so that's the string. So what we'll do is we'll save the string in variable x instead of variable r instead of the list, and then create another pattern where we are going to identify these numbers. Now it's easy. Now we just have these numbers digits in here, so we can simply say we need to match all the digits that are in there, and then save it in another variable vc where we have re is equal to find all p comma x or p comma r, and when we run this and look at vc, we should get a list of numbers 500 to 45 and 793, and that's what we get. So far we were able to successfully extract information about the company from the text using different types of regular expressions. Now it's time to combine this information and put it in a data frame. So we are going to create a company data frame where all this information will be saved, and to do that, what we are going to do is type dfc is the company the company data frame that we are creating, pd.dataframe, and open parenthesis, open curly braces, and within here we are going to create the column names in the dictionary as key value pairs, and the value would be c names. So there is a list in here that will be the column for company, and for email we have the list email that will be used here, and similarly we can create a column domain where the information for domain would be stored, and we have column for phone, and here we'll store the phone information, and beyond this then we have the saplings planted, so the number of saplings planted, and for that we have the variable sap that we are going to save here, and next we have the volunteers, and for volunteers we have the variable vc that which has that information. So when we run this and run for dfc, awesome, we now have a data frame which we extracted from this text. So going from here to here, and the regular expressions was what we used to get nice clean table of the data that we had initially, and this is now very useful, and now we can do other manipulations if we needed on this data set to do further processing. So that was one side of using regular expressions in to extract information from this particular string. Next we can look at some few more examples where we are going to extract information about different types of forest or annual properties for that particular forest. So let's see that. So data frame, we are going to create a data frame, and the way we are going to work with this now is we will split that entire string into a list and create a data frame out of that list. So for example, this particular line would be one row, then the second line would be a second row, and so on and so forth. So we'll split this string on this the dot at the end of each sentence. And to do that, the regular expression that we can write is p is equal to, in the quotations you want to type backslash dot, and then x is equal to re dot split p comma dt, and then dfl would be the data frame list that we are creating, pd dot data frame, and here we are going to create only one column which will label it as raw, and this will have the information from the string x. So before I run this, let me show you how the split string would look like. This is how the string would look like. This first sentence is broken up here, then we have second sentence, third sentence. So the list x, if we look at the length of list x, it has 21 sentences in there, and that's what we are going to use. And when we put this in the data frame form and look at DFL, this is the data frame we created based on the list that we created just now. So each sentence is a separate row in this particular data frame. Okay, now moving on, we can extract information from this. For example, if you go back to the main string that we are working with, the type of information that we can look for is billion. So here there is a cost somewhere, so this is the cost. The global estimated market size for the forest products is assumed to 60 billion in 2005 and 300 billion in 2020. So this entire string, we are assuming that it has data only for 2 years, 2005 and 2020. Next, we can also see here that there are new species of animals there, so we can use that information. So there are monkeys that have grown in numbers from 6 so up to 400, so that's that, 200 to 400. And then there are other types of birds that have increased in number from 500 to 2000. So we can get information about animals, birds, and also there are some reasons given here. So if we lower because, so sapling survival rate is lower because this is happening. So you can use the keyword because and try to find out if there are any reasons given for certain cases in this particular string that we have. In addition to this, we also can extract, we would have to extract the number for years, and we know that these are 4 digits, and we'll try to use that and see how we can extract that information. So let's go back down here, and to pull the information, what we are going to do is we are going to create a new column in the data frame DFL and add the information extracted using regex into that column. So let's first create a new column called billion underscore dollar, and what this data frame, what this column would store is information extracted about the $1 billion market size. So we'll say DFL dot, here we are going to look for the raw column, and we have not talked about this, but I'll explain it now. So we are going to use apply and lambda. These are advanced commands, but I'll show you how this works. So we are going to apply this particular function lambda to each row separately. So when we are applying it to this series, each value comes in to this function lambda as a x. So we can use x to process this further. Okay, so what we want to do is I'll put a condition if the dollar sign, which is this, if it exists in the string x that is coming in for each row, then what we want to do is add here, we want to do the find all regular expression. So here we'll use, so let's see, $1 billion. So this is going to be a dollar sign, so we want to escape it with a backslash, and then it is followed by digits, and after that that's it. So, and we are going to use it on the string x, and if that is not there, else if that condition is not satisfied, then we'll just put a np.nan. The reason why we are putting np.nan is because we can then use the drop command to drop all the nans when we are creating the final data frame. So if we run this and look at DFL, now we can see that this new column was created, and we were able to extract the 60 and 300 billion from this particular sentence right here. So that's really interesting. We can look at the sentence. If we do a df.iloc 15, and here, okay, it won't print everything. We can go back up to the string and look here. So this is the 60 and 300. So we are able to extract those two numbers from that sentence, and all other sentences that are not relevant are as nans, and that's really helpful because we can then drop all those rows from that data frame. Next, let's look at how we can pull reasons. So I'm going to create a new column called reasons, and for this I will use the same concept of apply and lambda. So DFL, and we'll supply the raw column to the expression. So DFL raw and dot apply lambda x, and here the regular expression again would be similar. So if because in x, if this is true, then we want to return the part that is after the x. So what we can do here is write re.find all, and we need the string that is after x, right? So, or we can use split, so that would be much easier. So we can do re.split, and we again split it on because, and the string is x that we are going to supply, and this re.split is going to return us a list with two parts. The first part would be before because, and second would be after. So we are interested in the after part, therefore we are putting a 1 there. Else what we want to do is np.nn. If that's not the case, then we just need nn values there. If we run this, now we can see that we have the part after because here. So this is the original sentence, and we have the last part right here. And awesome, we got 3 reasons in this data frame that if needed, those could be analyzed further. So we got that information. Next, let's look at if we can get the information about birds, and to do that we again use the same approach. And why don't we go ahead and copy this sentence right here so we can avoid typing again. Okay, now here we are looking for birds, and I'm gonna create birds. So we are cutting the sentence at birds, and I've already seen that this approach would work if it's if you are looking at a different string. You may have to first look at the word and see if it makes sense, and then proceed with this step. So here DFL, and now we were able to extract the sentence that has birds in them. So this sentence has birds, then that is the only sentence, all others are NN. So that's really nice. And after this we can use the similar logic to extract animals from this particular text. So animals, and here we would give the word animals, and again here it would be animals. When we run this as a DFL, we should see at least some sentence. Okay, we have one sentence that has animals in there and all others are NN, so that's again nice to see. Moving on, now we can go ahead and extract the information about years. So YEARS, and here what we are going to do is use DFL. Again we are going to use the raw and dot apply lambda x is, and here we are going to check a condition. If there are two conditions, so we'll check two conditions, this or this. Okay, so there we'll put two conditions here. The first condition is that the word years has it has to appear in X. If that appears, then the condition is true. The other condition could be years in X. So years or year, we can put year there, so without the S, in X. If that is there, then we say that that condition is true, and if it is true, then we are going to use the regex here, find all. And now we are just looking for the numbers for years, and there we can use within the code. So we know that it's going to be a digits, and we know that it's going to be 4 digits. So this is what we'll use, and the string that we'll supply here would be X. And if it does not satisfy this condition, then we can say else np.nan, and when we run this, we should see years for found in that rows. So let's look through this. Yes, so we found we are able to extract the year from this sentence and put it here, and there was another, these two are also years that we extracted and put them here. So as we can see, there are only 2 years, 2005 and 2020, and here we can see that these two are well aligned. So for 2005 the number is 60, 2020 the number is 300. So we'll focus on those for the next processing. Finally, we can look at the market size, and to do that we can say mkt size is equal to DFL and raw, and again dot apply lambda x is equal to, so x, and here we are going to say what the condition we are looking for. So if market, if there is market word, if this particular word market appears in the sentence, then we put the entire sentence in that column, else we put np.nan. And that was the last bit that I wanted to show. So we now have also created a market size column, and here we have pulled the information, sentences that have the word market in them, and we probably have already extracted the information about the market size and the year. Let's see how we can now use that further. So I'm going to create few more cells, and now we'll create pieces of the data frame, final data frame that we are going to create for the annual data. So get market size. So to get this information, we'll create a new data frame, df new, and in this what we can use is pd.dataframe open parentheses open curly braces. We can create a column called year, and right here we can directly use the list that is saved in this column for the 2 years, and we know that the location index for that is 15, so we are going to use the iloc. We'll use the loc and the column name, so loc, and we have 15, and then we use the column name years. Next we can pull the information on billion underscore dollar dfl.loc 15, then billion underscore dollar. And now when we look at the df new, we can see that we have successfully pulled the annual market size for the forest products for 2005 and 2020. So it's 60 billion and it has increased to 300 billion. That's awesome. Next, let's look at how we can pull information about animals from the same in the similar way. So get information for animals, and for this we are going to use x is equal to dfl animals, and we are going to use dot drop na. What that will do is it will remove all the NAs. So if we look at what we have is this, and there are a lot of NANs, and this is the only row we need from that data frame. So when we put a drop NA, we are essentially removing all of that and just leaving it here. Now to extract just the string part, we can add values, and what that does is we get just that string from out from there. And once we have this string, we can use the index 0 to pull the location of just that string from that array. So when we do that, we now have a string that can be processed further. So here if we say a underscore count is equal to re.find all, and we are looking for these two numbers in this string which shows the population growth for animals. In this case this is a monkey, and to do that we can say within quotes those are numbers, so we can easily separate those out with the \d sign, and we want it to look in the variable x. Similarly, if we wanted, we could also pull the name of the animal. So for example re.split, and we can split this string on the words such as. I'm sure there are better ways to do this, but for now I'm going to use this simple way. And when we split on this, the initial first string, so let me show you what I mean by that. So when we split this string, this is what we get, and from this what we are interested in monkey, which is in the second part. So I'm going to add 1 here. So what that will do is it will get us the second part, and now within this we can go ahead and split on the spaces and then just take the first one. So dot split again, and here if we use the space, then we get this, and from this we can get the index 0, and that's where we have the monkey. So I'm going to copy this and put it here, and thus for finally we can use the counts of and put it in df new. So we'll create a new column in df new called animal population, and for this we'll put the values that are in a underscore count, and then look at df new and see what we have. So this is what we have. We now have, in addition to market size, we also have the animal population listed here, and if needed we could also go ahead and add the name, but for now I'll leave the name out of the data frame. Finally, we can look at how we can get the information about birds from this particular text data frame that we have. So x, it will be similar approach. So x is equal to dfl. What we can do is we can go ahead and copy this entire code, put it here, and instead of animals we are looking at birds, and the method is the same. We are looking for the counts of population of birds, and therefore this string is valid. Now we are going to count the birds, so we'll say that we are not using this. I'm just going to remove that. And for birds, we should rename this and call it bird population. That is coming from the variable b underscore count. And we have error, oh sorry, spelling mistake. Okay, and we have the final data frame. We have the year, $billion, animal population, bird population. That's the information about the forest. And then up above we had another data frame, which is the DFC. Let me pull that one here again. And here we have the data frame that has the information about the company. So we, using regular expressions, we are able to convert this text and this large chunk of text into usable columns that have values that can be easily interpreted and easily processed further to do any analysis or comparisons. That was it for this video. I hope you enjoyed learning how the process of regular expressions work to extract data, and this is really helpful. I'll post a link below in the description which has a nice GUI to do regular expressions. So I'll see you all in the next video. Please like, share and subscribe. Thank you.